So we'll start with your potential divider rule.
Yes.
What is the potential divider? Can you explain?
Potential divider is a maximum voltage in a circuit.
Name itself, potential being divided. What is the potential? Potential basically is voltage.
Yes.
Right? So I have a cell, and if I want to divide it into 2 parts, 3 parts, then I would ideally use a potential divider circuit. It is nothing but either two resistances connected in series.
Yes.
Because in series current remains same, but the
Yes.
voltages change, right?
Okay.
So each resistance gets their own voltage,
Yes.
having the current same, and they will get the voltage with respect to their resistance. Say,
Yes.
suppose I have a smaller resistance and a bigger resistance. The smaller one will have less voltage, and the
Yes.
bigger one will obviously have more voltage because it follows the rule of I is equal to V by R or V is equal to IR. Makes
Yes.
sense?
Yes.
Okay, so let's see all kind of circuits that we can play around with.
So, sir, is a voltage, there's more voltage in a series circuit than in a parallel circuit?
More voltage?
Yes.
That's not the case.
Oh.
It is like, it depends from case to case, what you are taking and whom are you analyzing.
Yes.
You get me? You won't get it right now. Whatever I'm saying will be a bouncer. Just hold on. We'll understand that in detail. Just a second. Okay. So, if you see here, I have a resistor like this, and a resistor again, and then I have a cell, and I'm not connecting this thing. No key, no switch, nothing. What is this? This is a series circuit.
Yes.
Okay. If this is voltage V, if this is a voltage V, what will be the current flowing through the wire? Say I.
I is V of R.
Okay. Let this be R1 and this be R2. What is the potential difference, or what is the potential across this R1 resistor and R2 resistor? Can you tell me?
Would it just be V over I?
So the potential across, oh, sorry. The potential across the first resistance is going to be I into R1.
Yes.
And the potential across the second resistor is going to be I into R2.
Yes.
We know that. Who is the main supremo who is supplying the total voltage? The cell.
Yes.
So the cell will provide you with both the voltages V1 and V2.
Yes.
Right?
Yes.
And you can follow that V is equal to I into R1 plus I into R2. Make sense?
Yes.
So I cannot say that V is equal to I R1 plus R2.
Yes.
Okay. So I can say that I is equal to V by R1 plus R2. That way.
Yes.
Now, supposingly, I want to directly find out what is V1. I want to find out what is V1, but I'm not given the value of I.
Yes.
So can I not substitute this value over here in this equation? So I'll get V1, which is the potential with the R1 resistance, which is equal to I times R1 will be V upon R1 plus R2. The whole multiplied by R1. Make sense?
Yes.
So now this V1 is nothing but a part of this V only, this bigger voltage, right?
Yes.
And what is V2? It is V upon R1 plus R2, the whole multiplied by R2. These are the equations of your potential divider rule.
Okay.
It's just simply V is equal to I into R. We just found out the value of I in terms of capital V.
Yes.
And what is capital V? The driver cell's EMF, or we can say voltage.
Yes.
Does it make sense?
Yes, sir.
Okay. So we can say that they both, the V1 and V2, what you are getting there, has been divided.
Yes.
So we had total V, suppose, of 10 ohms, or sorry, 10 volts.
Yes.
So 3 volts went to R1, so 7 will go to R2 because R2 is a bigger resistance.
Yes.
So they will divide themselves or divide the voltage with respect to each other in a particular ratio.
Yes.
Let me say this is equation number 1 and equation number 2, right? If this is
Yes.
equation number 1 and 2, can I divide equation 1 with 2? So I get V1 upon V2 is equal to V upon R1 plus R2, the whole bracket multiplied by R1. V
Yes.
upon R1 plus R2, the whole bracket multiplied by R2. This gets cancelled. So what I'm left with is V1 upon V2 is equal to R1 upon R2.
Yes.
Isn't it?
Yes, sir.
So that's how the potentials will be divided. If you know one of the potentials, you can easily find out the other one by this formula.
This is
If you don't,
the
sorry,
this is the ratio, right?
this is a ratio. Yes, the voltages will be divided in this ratio of their
Yes.
resistance.
Okay.
The voltages will be divided in the ratio of their resistance. So if you want to find out, if you already have one of the voltages and both the resistances, and they're asking you what is the voltage across the next one, simply apply this formula.
Okay.
Suppose you don't know any of the voltages, but you know the overall voltage of the current of the circuit. Battery is PD.
Yes.
Do you understand? Battery is PD. Then you go to this formula.
Okay.
Okay, it will be a bit difficult for you right now to understand, but if you apply it to a situation, you'll understand. Have you
Yes.
copied it? Have you copied
Yes.
everything
Yes.
till this point?
Yes.
Even this ratio?
Yes, sir.
Okay, now let's take a practical example and you'll understand. So let me draw a circuit like this now. Just pardon my drawing because my pen isn't in best of the shapes. So it's going haywire. Okay, I've got two resistances like this. Okay, I'm giving an overall voltage of 5 volts. And this one has a resistance of 10 ohms. This one is having a resistance of 90 ohms. Okay,
Yes.
you are supposed to tell me what is the voltage across this resistance as V1 and what is the voltage if I'm reading in a voltmeter at V2. That's my question to you.
Okay.
Can you find it out?
So, sir,
Very.
would we use the ratio?
Hmm?
Oh, we can use the first formula. V1 equals V over
Yes.
R1.
Yes.
Okay. So, sir, how do you know which formula to use when? Like when to use the
By
ratio?
looking at what is given.
Okay.
So we have V, which is 5 volts.
Yes.
We have R1, which is 10.
Yes.
We have R2, which is 90,
Yes.
right? So now
Yes.
what makes sense is to find out V1 is equal to V upon R1 plus R2, the whole multiplied by R1. That's the
Yes.
best way, na? Because I know all the three things which are needed.
Yes.
I can easily find out what is V1 and I can easily again find out what is V2
Yes.
with the same formula. So it will always depend on what is given and what are you expecting to find out.
Yes.
That's so easy.
Yes, sir.
This is called as potential divider.
Okay.
Okay.
So,
Now,
is there a formula where you write V would the formula, because I wrote here in my book, V in equals R1 over R2 plus, no, R1 plus R2 times R1. Is that wrong?
yeah, V upon R1 plus R2, the whole bracket multiplied by R1.
Okay.
The R1 plus R2 thing is in the division or in the denominator.
Yes.
Okay.
Okay.
For this case.
Yes.
If I go the reverse way, we can also make a formula V is equal to R1 plus R2, the whole divided by R2 into V1 or V2. This is
Yes.
also a formula. But this would be used when one of the voltages is given and we want to find out what is the voltage of the battery.
Yes.
Right? So let's go to the next such question. Same situation. Now, the best part of this circuit is that both the resistances are fixed, so we don't have to worry about anything else. We don't know
Yes.
the voltage over here. We know that this is 10 ohms and we know this is 90 ohms. And we also know that this is having a voltage of V1, which is 1 volt. Can you calculate what is this V?
Would you just say, sir, R1 plus R2 over R2 times V2?
That is one way. Can you find out any other way? Very simple. That's way more simple.
Hmm.
You already know what is the voltage across this 10 ohm resistor.
Yes.
Can you not find out what is the current through it? V is equal to IR.
Yes. Yes.
I is
Yes.
equal to V by R.
Yes.
That's going to be 1 upon 10. So we know that 0.1 amperes current is running through the whole circuit. Now both of these are in series.
Yes.
So what is the overall resistance of the circuit? 100 ohms.
Yes.
So overall voltage will be equal to overall current multiplied by the overall voltage. Resistance. So 0.1 into 100 ohms. What is the answer? 10 volts.
Yes. Okay.
This is the easier way out. So
Yes.
it's not necessary that you always go for a complicated formula, learn it and do it. It can be done in an easy way as well.
Yes.
Okay, so you can solve one thing in a many different ways. So you just need to be smart enough to select the best one.
Yes.
Do you want me to keep it so that you can copy?
I've copied it, sir.
Okay. Now let's understand different situations. Now the things were easy because we had fixed resistances.
Yes.
Let's create a complication now. I have a fixed resistor.
So after this, I
Yeah.
have some questions from my book as well on circuit. I also want to do those.
Okay. Fine. But I don't think we would be able to accommodate all of that.
Yeah, all is fine, sir.
So let me just finish what I'm trying to do. I
Okay.
think you will be in a position to solve it on your own once I'm done with my explanations.
Yes. So what is the second? Is the second resistor variable resistor?
Yes, that's a variable resistor now. Now, when I have a variable resistor kept inside a circuit, will the overall resistance of the circuit be always same?
No, it will change.
It can change, right? So if I say this is 10 and this has a range from 10 to 90. Okay.
Yes.
So the minimum and the maximum value of the circuit's overall resistance will be 20 ohms se leke 100 ohms.
Yes.
Make sense?
Yes.
So now it depends what I am fixing my variable resistor as, and accordingly I'll be getting the voltage across both of them. Now the voltage across both of them is going to change.
Yes.
Let's consider this to be as 10 ohms or 10 volts. And let's say this variable resistor is having 90 ohms.
Yes.
What will be the division? 1:9?
Yes.
1:9. So one part will be given to the first resistor and 9 parts will be given to the next resistor. So 1 volt and 9 volt will be given.
Dividing to see in each resistor how much resistance is there.
Not in each resistance how much resistor. In each resistor, how much voltage is there?
Voltage. Okay.
Voltage. Okay.
Yes.
So you can see that because both of them are in a ratio of 1:9,
Yes.
the overall voltage is also divided in the ratio of 1:9.
Okay.
Now let's say I have 10 and 10. 10 ohms here, 10 ohms there. So how
Yes.
will be the voltage divided?
One
Equally,
is
1:1.
yes.
When I say 1:1, 10 volts can be divided as 1:1 as 5 volts and 5 volts.
Yes.
So now the voltages are changing according to the value of this variable resistance.
Yes.
And it is changing for both of them, this one as well as this one.
Yes.
The voltage is not remaining same.
Yes.
Okay,
Yes, sir.
makes sense. So this is another type of potential divider.
Yes.
Let's make it further complicated. Now this is a rheostat, my mistake. This is a rheostat. What is this?
Rheostat.
What does the rheostat do?
So is rheostat the same as variable resistor?
Yes. But the thing is, variable resistor does not have two parts. The rheostat can have two parts. So I can
Okay.
have a voltmeter here in between this part, and I can have a voltmeter in between this part and this part.
Oh, okay.
You understand?
Yes, sir.
So rheostat basically is one resistor, single resistor, which has two parts to it.
Yes.
And this is called as a jockey. This pin or this part is a jockey, which I can move over the entire resistance or the
Yes.
coil. So suppose I keep this at this position.
So is a jockey the arrow? Or
Yes,
the line?
jockey, okay, you can say that is a jockey.
Okay.
So if I take my jockey to the highest position available over here at point, say A,
Yes.
so how much will this V1 be and how much will V2 be if this is 10 volts? Ideally, V1 would become 0.
Yes.
Are you really comprehending or just saying yes?
Well, if you push, I guess if you push it to the furthest side, the resistance decreases, right?
Of what?
Ah.
Of
The
this part. Of this
of
part.
A. Yes.
Of this part, which is on the upper side of the jockey. And
Yes.
the lower side of the jockey is another part of resistor.
Yes.
Okay. So because it is at 0, the voltage will be 0 and the voltage in the lower section will become 10 volts.
Yes.
Okay. Supposingly, I don't do that and I keep it exactly at the center.
Yes.
So what will happen? They will equally divide. So 5
Yes.
volts and 5 volts. So
Yes.
if I keep it at 75% over here, so 75:25, upper part,
Yes.
lower part. So
Yes.
7.5 volts over here and 2.5 volts over here. This would be the ratio. So ideally, in this case of a rheostat, again, both the voltages will change.
Yes.
Upper part as well as lower part. I can also have a rheostat being placed over here. See, in this case, here. Pay attention here on the board. I can place my rheostat over here instead of a variable resistor.
Yes.
So the voltages across this one will also change, and rheostat itself will have two more resistances to play with. So now it
Yeah.
will depend which are we considering.
Yes.
Okay. Complication understood?
Yes.
Now let's see what complications are asked in the exam. So they normally give you a situation where I have a LDR and then I have a thermistor. Okay.
Yes.
Now there is an LDR and there is a thermistor. Don't you think both of them have variable resistances?
Yes, they do.
Okay. So I can connect something to this, say LDR. So I will connect it to my lamp. I have a lamp. And thermistor, I'm connecting it to my AC, air conditioner. Okay.
Okay.
I'm
Yes.
just connecting my air conditioner over here. So I'm living in Canada, supposedly. I'm
Yes.
living in Canada. And I know that I am going to work till 7 p.m. in the evening.
Yes.
And at around 5 p.m., it is really very dark.
Yes.
And I have my dogs and my plants in the house. So I want the light to be on.
Yes.
Secondly, it's also very cold outside. So
Yes.
I want before I enter my house, the house should be nicely warm.
Yes.
So can I connect a heater as well?
Yes.
Okay. So what will the LDR and the thermistor do? The LDR will be stuck at my roof.
Yes.
As the
Yes.
intensity of the light decreases,
Yes.
what will happen to the resistance of LDR?
It will increase.
It will
No,
also
no.
increase, right?
Yeah.
The resistance will increase. So don't you
Yes.
think the voltage across LDR will grow?
Yes.
Okay. And if the voltage is growing, then at a particular point of time, the lamp will start glowing because it is getting enough voltage. So my
Yes.
lamps and my lights will start glowing.
Yes.
And what will my thermistor do? If the temperature is going down,
Yes.
so my resistance of the thermistor will increase.
Yes.
Again, that will also receive some more voltage.
Yes.
And that voltage will be given to my heater and it might start working. So in between, I'll just keep one relay also, because obviously this is a very, very small DC circuit. And
Yes.
heater I'm operating at a very high value, or in the AC circuits.
Yes.
I can have a relay in between to operate the AC to DC thing, right? Make sense? How everything is connected now?
Yes.
Okay. So this is the most complicated area where you can play with.
Yes.
So you will have to explain what happens if the LDR's resistance goes down, what happens if the light's intensity goes down, what happens if the temperature goes down. So accordingly, the resistances will change.
Yes.
Because of the resistance, the potential will change, and
Yes.
hence the division will change. And ultimately, you might give here some signals, or you might accomplish some task on the basis of the voltage.
Yes.
These are the questions which would be asked to you.
Okay.
Got it?
Yes, sir.
All the complications covered.
Yes.
So we have learned about, first we started with a normal potential divider circuit. Potential divider, always remember, it is 2 or 3 resistances in series.
Yes.
Okay, connected in such a way, in a standing circuit or a sleeping circuit, doesn't matter. This was the
Yes.
most simplest way, where resistances have a fixed value of resistance.
Yes.
These are of no use actually to us, because they have fixed value of voltage. What will I do? I know already.
Yes.
There is no use, but we can understand the concept through it. And we come down to a formula: V1 is equal to V upon R1 plus R2 multiplied by R1 if we want to find V1. And
Yes.
V2 is equal to V upon R1 plus R2 multiplied by R2 if we want to find V2. What is V
Yeah.
upon R1 plus R2? Basically, it is nothing but the formula for current.
Yes.
Formula for current. So once you find the current in the circuit, obviously you can find the voltage of that part of the resistance simply by multiplying the current with the resistance.
Yes.
Make sense?
Yes, sir.
Then we took the complication the other way. If suppose one of the voltages is given and this is not given, so we went the simplest way.
Yes.
Complication number 3. We took one resistance as fixed resistance, the other one as a variable. So both of them were having a variable voltage because the ratio of resistances was changing again and again.
Yes.
Ultimately, we came down to a rheostat. Again, when we change the rheostat's jockey or we change the position of the jockey, the resistance in the upper part and the resistance in the lower part again keep changing, and hence the voltages will keep changing in the upper and the lower parts.
Yes.
Complication number 4 done. Complication number 5 and the most complicated area will be having an LDR and a thermistor all together.
Yes.
Okay.
Yes, sir.
So what happens over here? Again, on the basis of the intensity of the light received, they will change their resistances and accordingly change the voltages they share.
Yes.
Normally, they should be one in a circuit, one in one circuit, but we can also have combination of them if it is not getting affected.
Yes.
So it cannot be so simple a circuit because we'll need some more switches, we'll need more relays and stuff. But this can be a possible scenario which can be asked in your questions.
Yes.
Make sense now?
Yes, sir.
Okay. One last part before we wind up for the class. It's not concerning this, but it is this. R is directly proportional to length. You know this?
Yes.
If the length increases, resistance increases. And R is inversely proportional to area of cross section.
Yes.
So if the area of cross section of the wire increases, the resistance drops. And
Yes.
therefore, we always have thick cables. Why do we have thick cables? So that their resistances are less.
Yes.
Okay. Can I make a mixed proportion out of it?
Yes, sir.
Okay. Now, I have not done the basics with you, but if you want to convert a proportionality into an equation, what do you need to do?
Would you
If you want to convert a proportionality into an equation, you will have to put a constant.
yes.
Okay, this is a math situation. So proportionality to equation, we always need to put a constant, and the constant in this case will be rho, which is called as a resistivity. What is this?
Resistivity.
Resistivity. Is this portion there for you?
Yes, it is, sir.
R is equal to rho LA. Okay.
Yes.
Do you understand Hindi? Role, Rona, Rona.
Yes.
What is Rona? Crying.
Right. Yeah.
So what we say is a rolling. Did you see my action? A rolling. A rolling. Ro la a. If you're not comfortable with the Hindi thing, R is equal to rho times L into L upon A.
Yes. So, sir, what the row part is that the cons no the
It's a
resistance.
constant. It's a
Okay.
constant called as resistivity.
Okay.
Okay. Now
What is the
remember
base
this.
that?
I'll give you an explanation. I know that you're not getting. I do know that. So tell me, if I have a gold, if I have resistances of made up of carbon, can I have resistances of carbon of same value? All the resistances? Not possible. We can have different values, right?
Yes.
But the resistivity of carbon as a material will be same.
Yes.
It's like density. Density of iron is same,
Yes.
but it depends what are you making. Are you making a ship or are you making a nail? Its mass will change.
Yes.
So similarly, the resistivity of the iron will be same, but it will depend on how big or how small are you taking the resistor to be, so that its resistance will change. So the
Yes.
length can be different, the area can be different, right?
Yes.
The length and the areas can be different, and accordingly the resistance's value will change. But
Yes.
resistivity will always remain same.
Yes, sir.
So resistivity is something which will always be a constant. Resistance can change for a given material.
Okay.
Okay, make sense?
Yes.
Okay, so that's R is equal to rho L upon A. We can also make a because this is a mixed proportion that we have, R is proportional to L upon A. We can also say R1 A1 upon L1 is equal to R2 A2 upon L2.
Yes.
Okay.
Yes, sir.
So we'll do the questions based on these in the next class. We'll start from here.
Okay.
And then we'll jump on to the next concept.
Yes.
I think mostly the potential divider, NTC, PTC, and your LDR is done. So
Yes.
electricity is ideally complete.
Yes.
Okay.
Yes, sir.
I think we'll wind up here. That's
Okay.
enough for the day. You can solve questions based on the potential dividers
Yes.
and get it in the next class by then.
Okay.
I've not seen the PDF that you have sent. Okay. We'll just
Okay.
see it then. And we'll continue.
Okay, sir. So when can we have our next class?
The problem over here that we are facing is we are having holidays over here.
Okay.
But tomorrow we have festival and we have holiday, and we'll be starting again from mostly Monday. If at all I'm back over here
Okay.
on a Sunday or something, I'll definitely get back. When is the test due?
Well, test is on Friday, sir. But we've covered a lot, which I think will help.
Okay, okay. I don't think there'll be problem for your test then. This is enough for you. Mostly we
Yes.
have covered everything.
Yes.
Only that R1, A1 upon L1, just try to solve some questions on that. If at all you
Yes.
don't get the answers or you don't understand, might be some videos will help.
Yes.
Okay, you can easily crack that. There's nothing difficult.
Yes.
And you
sir.
can also post it on WhatsApp. If I get time, I'll definitely revert to you.
Okay.
Okay. Or we
Okay,
can
sir.
have a call if there is something that you don't understand. I
Yes.
can definitely spare 3-4 minutes or 5 minutes max. But
Yes.
otherwise, I'll be a bit busy with other things. Okay.
Okay, sir.
Fine. So that's all for the day.
Yes.
Do you have anyone today as well, or no? Nobody.
No, not today as well. Sorry, sir.
Okay, okay. Your mom and dad both are working?
Yeah, they are.
Okay, so when do they come back?
Well, my parents are working, but they went to buy something for
Acha,
school.
acha, acha. Okay,
You
okay,
know.
okay. Fine.
Yeah.
So what time do they come back normally?
Normally they come back by 5. It's 4:30 currently, so they'll come back in half an hour.
Okay. What happens is normally 9:30, 10, I also go to sleep over here.
Okay. Hmm.
So ideally at around say 6:37ish, I'm already asleep.
Yes.
So that's why we aren't able to talk. But I'll try to have a word today or maybe tomorrow.
Okay.
Tomorrow I'll be a bit free. I'll try to talk. Okay.
Okay, sir. Yes.
Okay. Bye. Take care.
Bye. Bye.
Sure. Bye bye.